You're walking with genetic switches you don't even know are flipped. While most people are stuck with standard issue DNA, a few of you are running custom firmware. And the wild part? You might not realize it until someone points it out. Here are 8 rare genetic switches that could be hiding in your body. Number 1, the short sleep gene. Most people need 8 hours of sleep or they're useless. You need coffee, willpower, and a small miracle just to function. But certain people have a mutation in the DEC2 gene that lets them sleep 4 to 6 hours. They wake up feeling like they just won the lottery. No grogginess, no afternoon crash, just pure sustained energy all day long. This isn't willpower or good habits. It's a genetic mutation that keeps orexin levels high. Orexin is a neuropeptide that promotes wakefulness. The DEC2 mutation prevents the gene from suppressing orexin, so you stay alert on less sleep. And here's the kicker. People with this mutation don't just sleep less, they live longer. Fruit fly studies showed extended lifespan, better memory, enhanced stress resistance, and improved mobility late in life. The mutation boosts mitochondrial respiratory capacity, meaning your cells literally produce energy more efficiently. Researchers at UCSF have identified over 50 families with this trait, and it occurs in less than 1 in 4 million people for certain variants. So, if you naturally wake up after 4 hours feeling amazing, you're not sleep deprived, you're a mutant with a superpower. Number 2, lactose persistence. If you can drink a glass of milk without your stomach staging a revolt, congratulations. You're a mutant, and you're in the minority. About 65 to 70% of adults worldwide are lactose intolerant. That's the default human state. Lactase persistence is the mutation. Most mammals stop producing lactase, the enzyme that breaks down milk sugar, after weaning. It makes sense. Why keep making an enzyme you don't need? But about 10,000 years ago, when humans started dairy farming, a mutation appeared. The mutation keeps the lactase gene switched on into adulthood. In Northern Europeans, about 90% have it. In East Asians, only about 10%. The mutation spread fast because it gave people access to a new food source: milk, cheese, yogurt. Suddenly, you could survive famines better if you could digest dairy. This is gene culture coevolution in action. Different populations even evolve different mutations for the same trait. Europeans use one genetic solution. Africans and Middle Easterners use others. So if you're chugging milk with zero consequences, your DNA adapted to dairy farming. If you're bloated and miserable, you're running the original factory settings. Number 3, high-altitude oxygen gene. Certain people's lungs function like cheat codes. Tibetans and Andeans can thrive at altitudes where the rest of us would be gasping like fish out of water. The secret is a gene called EPAS1. It regulates how your body responds to low oxygen. At high altitude, most people's bodies panic and overproduce red blood cells to carry more oxygen. Sounds good, right? Except it thickens your blood, slows circulation, and causes serious health problems. The EPAS1 mutation prevents that overproduction. Tibetans with the adaptive variant maintain normal hemoglobin levels even at extreme altitude, but their bodies use oxygen more efficiently. 87% of Tibetans carry this variant. Only 9% of lowland Han Chinese have it. That's one of the strongest examples of natural selection ever documented in humans. And here's where it gets wild. The Tibetan EPAS1 variant came from Denisovans, an extinct species of humans. Tens of thousands of years ago, our ancestors interbred with Denisovans, and a portion of them inherited this high-altitude adaptation. It's adaptive introgression, ancient DNA giving modern humans survival advantages. So, if you're a Sherpa casually working on Everest while tourists are dying, thank your Denisovan ancestors. Number 4, the muscle fiber switch. Your DNA decided whether you're built for speed or endurance before you ever set foot on a track. The ACTN3 gene codes for a protein called alpha-actinin 3, found in fast-twitch muscle fibers. Fast-twitch fibers are for explosive power, sprinting, jumping, lifting heavy weights. You either have 2 working copies of the gene, 1 working copy, or none. If you're RR, both copies work. You've got full alpha-actinin 3 expression. More fast-twitch fibers. You're built like a sprinter. If you're XX, you have none of the working copies. Your body compensates by optimizing for endurance. You're built like a marathoner. Studies of elite athletes show this matters. Olympic sprinters are enriched for the RR genotype. Endurance athletes often have XX, and the distribution follows geography. The XX genotype is more common in populations farther from the equator, possibly due to climate adaptation. Jamaicans who dominate Olympic sprints have only 1% XX frequency. So, if you're slow at sprints but can run forever, or fast in short bursts but gassed after a mile, blame your ACTN3 gene. It's not lazy, it's specialized. If you're finding this interesting, consider subscribing. I drop videos like this regularly. Anyway, back to it. Number 5, the cilantro soap gene. If cilantro tastes like you're eating a salad washed with dish soap, your DNA is confusing your food with cleaning products. And you're not crazy. It's a genetic variant in the OR6A2 gene. OR6A2 codes for an olfactory receptor that detects aldehydes. Aldehydes are chemical compounds found in cilantro. They're also found in soap and in the defensive secretions of stink bugs. People with certain OR6A2 variants are hypersensitive to these aldehydes. So, when you bite into a taco with cilantro, your brain lights up the same receptor as if you just licked a bar of soap. The prevalence varies wildly by ancestry. 21% of East Asians hate cilantro, 17% of Europeans, only 3% of Middle Easterners. Cultural exposure plays a role too. Populations that use cilantro heavily report lower aversion rates. But the genetic component is real. Celebrity chefs like Julia Child and Ina Garten publicly hated cilantro. There's even a website called hatecilantro.com. So next time someone tells you cilantro tastes fresh and citrusy and you're tasting soap, it's not preference, it's perception. Your OR6A2 receptor is doing exactly what it's supposed to do. Detect aldehydes. It's just that cilantro happens to be full of them. Number 6, alcohol flush reaction. If one beer turns your face into a tomato, congratulations. Your DNA installed a built-in anti-alcoholism system. It's called ALDH2 deficiency, and it's common in East Asians. About 30 to 50% show symptoms. The ALDH2 enzyme normally breaks down acetaldehyde, which is a toxic byproduct of alcohol metabolism. The ALDH2*2 variant dramatically reduces that enzyme's activity. So, when you drink, acetaldehyde accumulates instead of being cleared. That causes facial flushing, rapid heartbeat, nausea, and headaches. It's extremely unpleasant. And that's the point. People with ALDH2*2 have lower rates of alcoholism because drinking feels terrible. It's a natural deterrent. But here's the dark side. If you have the mutation and you drink anyway, your risk of esophageal cancer goes up 4 to 8 times. The acetaldehyde buildup causes serious cellular damage. Recent research even links ALDH2 deficiency plus alcohol consumption to increased Alzheimer's risk. So, if you turn red after one drink, your body is screaming at you to stop. It's not weakness, it's a genetic warning system, and about 540 million people worldwide have it. Quick reminder, if you're enjoying this, subscribing really helps out. Now, where were we? Number 7, blue eyes. If you have blue eyes, you're related to every other blue-eyed person on Earth. All blue eyes trace back to a single mutation in one person. This individual lived 6,000 to 10,000 years ago, probably near the Black Sea. The mutation is in the HERC2 gene, which regulates the OCA2 gene that controls melanin production in the iris. The ancestral version allows melanin production. Brown eyes, the mutant version reduces it. Blue eyes. A 2008 study analyzed blue-eyed individuals from Denmark, Turkey, and Jordan. Every single one shared the exact same genetic haplotype, same 6 polymorphic SNPS, proof of a single origin. Blue eyes didn't evolve multiple times. They arose once in one person and spread. Today, about 8 to 10% of the global population has blue eyes, but in particular regions, it's nearly universal. Estonia and Finland hit 89%, Iceland 75%. The mutation spread rapidly during this great agricultural migration into northern Europe. So, blue-eyed people are technically one big extended family, which explains why everyone in Scandinavia looks vaguely related. They are. Number 8. Pain sensitivity gene. Imagine never feeling pain. Sounds like a superpower, right? Now imagine not knowing you broke your leg until you see the bone sticking out. The SCN9. A gene encodes a sodium channel called NAV1.7, which transmits pain signals in your nerves. Loss of function mutations in SCCN9 cause congenital insensitivity to pain. You literally cannot feel pain, burns, fractures, infections, nothing. People with this condition often lose parts of their tongue or lips from accidental biting during childhood. They bite down and don't realize they're injuring themselves. Almost 20% die before age 3 from hyperpyrexia. Extreme overheating. Their bodies can't sense internal danger signals, so they don't know to cool down. The same gene, with different mutations, causes the opposite problem. Gain-of-function mutations make the NAV1.7 channel overactive. People with those mutations experience extreme pain from minor triggers. A light touch feels like fire. So, SCN9A is a perfect example of why pain exists. It's not punishment, it's a warning system. Without it, you suffer severe injuries, infections, and early death because you can't detect harm. Pain sucks, but it's literally keeping you alive. So next time you stub your toe and scream, be grateful. Your SCN9A gene is doing its job. Thanks for watching. If you enjoyed this, subscribe and hit the bell so you don't miss the next one. See you.